So, as we've talked about sets and sample spaces, we also need to talk about the different kinds of operations that we can do on them. So to illustrate, I have a sample space consisting of all the whole numbers between 0 and 100, and I have two events or subsets of S. So we would write that A is a subset of S, B is also a subset of S, so that symbol means subset. And we are going to talk about a few different operations on these smaller sets, or we'll also call them events later on. So the first kind is union, which is sometimes represented as OR, and symbolically we'll write A and then this cup symbol B. Now when we say OR, we mean mathematical OR. So we're not excluding any numbers that happen in between. So it's all odd numbers in S, or all the elements in B, or something that's in both. So A union B would be, you would list off everything that's in A, and then, so that would be what? 1, 3, 5, ... all the way up to 99. And then anything that is in B that we haven't counted already. So that includes 0, 2. Notice that we already have 1 and 3, so we don't have to write it again. 12 and 100. You can rewrite them, put them in order properly if you want. But then the idea is, symbolically, if A, we're going to represent as this circle here, and B is this green circle here. A union B is everything in A and in B and in the middle. As for intersection, the keyword there is going to be and we represent it as A, and it looks like an upside down cup, B. For intersection, we're only going to include the objects that are in both sets. So all odd numbers that are in B, or in other words, all the numbers in B that are also odd. So that would be 1, 3, and 29. Nothing else. So with intersection, rather than talking about what's in A or B, we're just going to be talking about what's in both. Lastly, complement. So that's not an interaction between both, or that's not an operation between A and B. It's an operation on one of these in relation to the larger set it's in. So basically we mean everything except for, and the key word is not. So whatever is not in A, we might represent that as A raised to the C. So that's C the notation we're actually going to be using is A bar. Okay? And with A bar, what we're saying is to take everything that's in S that's not in A. Okay? So if A is all odd numbers, now we're talking about all even numbers, including 0. So that'd be 0, 2, 4, ... up to 100. Similarly, what's the complement of B? It's everything that's in S that's not in B. So throw out what B is, and then that will be your A set. So 0 is in B, so don't put that in there. 1 is in B, don't put that. Everything up to the first one that doesn't appear is 4, and then 5, then ... and then up to 11, but you have to skip over 12. 13, dot, dot, dot. Again, skip over 29, 28, 30, dot, 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 and end at 99. So complement you can think about as, instead of thinking about A and B, so remember this is A and this is B, you're thinking about A and B as living inside of S. And so the complement of A would be everything that's not in A. So excluding this. And similarly for the complement of B.